Hi guys, I'm Darren, and in this video we'll be checking out iNav Auto Launch. I already have a video out about Auto Launch which I did quite a while back, but since I've done that video there are a few things that have changed in Configurator. There are also some new parameters that may help people, especially if they have larger models. So what we're going to do is revisit Auto Launch, just go over the features again, check out the new features, and we'll go over how to set it up. Plus, if you're not confident with powering your model up to feel the weight of it and when it starts floating, I've also got a useful tool that can estimate the power that you need to set for those specific settings. So what we'll do first is plug this thing in and jump into iNav. Right, so the USB is plugged in, so let's connect to the plane and head into the advanced tuning page. This is where pretty much all the auto launch settings we need are. There's only one setting that's not on this page that we might want to use, but we'll go into the CLI in a minute and have a look at that. But first of all, let's take a look on this page. So the first thing that you may notice compared to the older video, which I believe may have been iNav 2.4, is the order of the parameters is different now. And the idea is that from the top, you have basically just enabled auto launch and set it up. And at the bottom is the end of the launch. So as the list progresses, you'll get stuff that's happening in time sequence. So before going into these settings, I should probably explain the sequence for using auto launch, because there are a lot of places where they say a sequence, but it's not quite right. And the sequence that will work with both versions of auto launch and will work every time is this. Right, so first of all, make sure that you are in a non-navigation flight mode. So that can be manual, acro, angle, or horizon. Make sure that you have not got altitude hold enabled. If you use our altitude hold on angle, then you would need to use a different flight mode. The reason behind this is that navigation flight modes can stop you arming, which is a very good thing, because if they've got auto throttle, that may start up while you're on the ground. The next step is to enable auto launch, or if it's permanently enabled, then forget that step. Next, you would arm the model so it's ready to go. And at this point, you can choose a flight mode that you exit into. So if you wanted to loiter, for example, you could select position hold at this point. Next, you raise your throttle. And at this point, either the motor will do nothing, it will go to idle throttle, or it will have a delay before going into idle throttle. So if you have no idle throttle, you're ready to launch it. If not, once your idle throttle is running, then you're also ready to launch. So throw the plane. That's it. You don't need to jerk it to get it spinning. That's really not the right way to use auto launch. I've seen a lot of people do it, but it's wrong. It can cause I-turn problems. So literally just throw the plane. That is the way auto launch is designed to work. At that point, it will climb up, hopefully, if all settings are right. So that's the procedure for getting auto launch working. So what I'll do is grab the plane and we'll go through these settings. So the idle throttle is basically how fast the motor is going to spin when it's ready to launch. By default, this is 1000, so it means that the motor will not spin at all. So why would you want the motor to spin before you actually throw the plane? Well, if you notice, mine is set to 20%, which is a really low throttle. It probably could actually cruise about on that just about, but it's not enough to launch. Mainly for me on this plane, it is an indicator to show that it is ready to throw it. Once I see that 20% throttle, I know that I can throw the plane and the launch will work. However, the more useful reason for having idle throttle is if you've got a heavier plane. For example, my AR wing, which is 999 grams, I have my idle throttle set to 50%. And what that does is not only does it give me a little bit of an extra push when I throw the plane, but also it helps keep it straight because the thrust is obviously trying to push in a straight direction. So it can be a nice assist for getting the plane up in the air. So they're the two reasons why you would set idle throttle. Next up, we have the throwing angle. Now, by default, this is set to 45 degrees, which, is that, which should be fine for most people. Unless you have a really bad throw, 45 should be fine. I've set mine to 60, which is, what about that? It's a little bit more than 45. just for a little bit of slack, just in case I do give it a bad throw. We're all human, aren't we? The only time that you might want to go higher than that is if you do like an overhead launch. But again, it only needs to be like 90 degrees, because if you're doing an overhead launch, it's that sort of angle, which is what, about 70, 75 degrees. So setting it to 90, which is straight up, there's still plenty of scope for if you get that wrong. So there's no real reason to ever set this to something massive like 180. 90 is the most that you should ever really need to set this to. So at this point, we're on the ground still, and we've just said how fast we want the motor to spin when we're ready to launch, and we've given an angle that we want that launch envelope to be within. So the next step is detecting when we've thrown the plane. And these next three parameters are what does that. So the first one we have is threshold velocity. And what that is the speed that the plane is moving, or the minimum speed that the plane is moving, I should say. By default, this is 300. So it's 300 centimeters per second, which for small things, it's usually fine, but we will be tweaking these just to make sure that the detection is good for our aircraft. The next is the acceleration threshold. And what that is detecting is the rate at which the plane is speeding up. If it's speeding up all the way through the launch throw, it will know that it's accelerating to launch. So by default, this is set to 1863. And the final setting in those three is detect time. And that is that you need to be at least the threshold velocity and accelerating at least the threshold acceleration for at least 40 milliseconds. Once all those three are met, it will say we're launching and trigger the launch. So why would you change these settings? Well, first of all, detect time, don't change it. It's an absolutely fine value as it is. To be honest, I don't really know why it's in configurator. It's one of those values you never really touch. But however, threshold velocity and acceleration you can tweak to the plane. So the best way to do this is actually to simulate some launches. So get a battery in here, get your transmitter all set up, and maybe just set the launch throttle to quite a low value so it's not actually doing anything when it detects. You just want to know the difference between this and this. So if this is set to 1,000 or if this is set to 1,000 or 1,100, maybe set this to 1,300 so that you can hear the difference, but it's still not really pushing the plane. Of course, still be careful. It's still a spinning prop. It can still damage fingers, arms, faces, everything like that. So be vigilant with this, but the best way to do it is to simulate how you're going to throw the plane. So for me with this plane, I do just grip it here and throw it pretty much straight, maybe with a slight upwards angle, but I will give it that motion, which is how I would launch it in the field. If the prop speed changes or the motor starts up, however you've got the launch throttle and the idle throttle set up, then you know it's fine. If it doesn't, you can try lowering these settings very slightly. So maybe reduce them by maybe 50 at a time, 100 at a time at most, and just get it so that when you throw that plane with the same effort that you'll actually give it at the field, it will trigger the motor to speed up. Once you've got that, you know that these are set right for that plane with how you're going to launch it. I appreciate that indoors this might not be the easiest thing to do. So especially if it's big, that's what I'm demonstrating with this, because I can do everything at the desk. But for example, with the I'm setting up for Dragon 2, I could just about do that at the desk, but the AR wing I've had to sort of do at the field. Once you're happy with the detection, we can move on to the next parameter. So the next parameter is motor delay, and by default that is set to 500, which is quite a long time. It's half a second. The idea with motor delay is that the prop has cleared your hand before it increases in speed, either from 0 or from idle throttle. It's quite an important thing to get right, and unfortunately the only way you should really tune this is by gradually lowering it. So if you find that it's taking too long, the plane dips down, you might end up with a couple of failed launches. But it's better to work that way than have it too small and it carve your hand up. I mean, of course, if you follow through with your hand when you launch the plane like you're supposed to, you should be clear of a prop anyway. Still be careful when changing this setting. The last thing you want is for it actually to go through and injure you. Of course, if this was a tractor plane with maybe, for example, a twin motor, where the motors are completely clear of my hand, I could set this up to 0, because as soon as it's detected the launch, it could go full power. My hand is completely clear. There's no danger whatsoever. So again, like every setting on this, it depends completely on the model. The next setting is actually not related to the plane at all. This is related to your transmitter. This is the minimum launch time. So by default, this is set to 0, so it's turned off. What this setting does is basically will ignore any stick input for those first 2 seconds after the launch has been detected. If you launch when you're holding your transmitter in one hand and the plane in the other, and you throw it and accidentally bump the transmitter, it will cancel the launch and your plane will go into the deck. Say if you've got the transmitter on the floor, you throw the plane, you accidentally step backwards onto the transmitter, it will cancel the launch and the plane goes down again. So this minimum launch time is basically a safeguard against stuff like that happening. Also, if maybe you've got it on the ground, you pick it up, you knock something. So depending on your situation, how you fly, you may want this on, you may not. If you do have a problem with the launch, however, the only thing you can really do is disarm it. So that's one thing to take into consideration. If you do have a failed launch or it starts going off in the wrong direction, the only thing you could really do is disarm it. If it's high enough, you could probably rearm it and take control back. But again, it's one of these things that you need to set for the best outcome for most situations. Next up, we have motor spin up time. Now, let's see. Default is 100, so I've not changed it. In most cases, you wouldn't need to change it. What that is the amount of time it takes for the motor to either increase from no throttle or idle throttle to the launch throttle. For most planes with a fixed prop like this, the 100 is fine. If you're using a folding prop, you would want to increase that. And the reason being, if a prop just springs out, especially if it's a low quality folding prop, it can weaken around the pivots and it eventually snap. I was looking up there, but in my car, I've got a Durafly Excalibur. That prop snapped at the hinge point. So it does happen. That's why this settings here. If you've got a folding prop, increase that to maybe 500 even, that should be fine. And it will just spin up slower and you'll have less stress on the motor and prop, that sort of thing. The next setting is the launch throttle. This is the throttle that it uses after detection to make the model climb up. As I mentioned earlier, it doesn't matter what your throttle stick is set to. That's for when the launch finishes. That's your cruise throttle effectively. This setting here, launch throttle, is the throttle used to climb up. There's 2 methods for calculating this, and we'll go through both of those in a minute. The next setting is the climb angle, and this is how steeply the plane will actually climb. So by default, I believe it's set to 18 degrees. Yeah. Which, if you've got something that needs to get airspeed up before it climbs, is a great setting. So for a mini Talon, that sort of thing, 18 degrees is perfectly acceptable. If you got something like this or a Drac where it's got so much power it can just climb for days, you can set that to basically whatever you want. As long as the motor can provide enough thrust to get it up, the angle is up to you. So I've set this one to 30 degrees, which probably about that, which where I fly, it's plenty enough to clear trees and everything in the surrounding area. It's absolutely fine. So again, this angle depends on the plane that you have and what its capabilities are, but also your surrounding area. So again, it's something that you guys need to sort of decide. The next 2 settings, other than moving your sticks after the launch time, are what are used to cancel the launch. So earlier we mentioned this minimum launch time. If at any point after that time you want to exit the launch, you can just move your aileron elevator stick and it will abort the launch at that point and you can take over. If you don't do that, then these two parameters here are what will decide if the launch has finished or not. So the first one is the launch timeout. Now this is the maximum time allowed for the launch after detection. So from this detect point here, we in this example have 10 seconds that the launch will work. After the 10 seconds, it will exit the launch, do the end transition if you've got it set, and then go into the flight mode that you've got set on your transmitter and the throttle level that you have on your transmitter. The other setting, maximum altitude, will do the same thing. So in this example, I've got it set to 91 meters, 44 centimeters. So that's probably something like 300 feet. So if you get to that altitude, it will end the launch at that point. Now, I believe whichever one of these two you get to first will exit the launch. And the next parameter is what happens when the launch exits. On 2.4, when you exited the launch, it would come up and then just basically snap to the altitude that it's currently at and then to whatever flight mode you've got set. The end transition time will actually have a nice transition from the launch angle to the flat angle. It's mainly a visual thing, but it is just a nice smooth end to the launch. And the end transition time is the amount of time that takes. So I've got mine set to 3 seconds. The default is 2 seconds, but it's up to you. You can have this as long as you want. Well, up until 5 seconds is the maximum you can have it. If you want just the snap straight to level, you can set this to 0. So those are the settings in Configurator, but there is one other setting that is particularly useful if you've got a larger model. And to be honest, I think it should be in Configurator more than detect time should. So I might even swap them over. So iNav 5 maybe will have something different. So if we'll pop into our CLI, and what we're going to do is type get idle. And it's this last setting here, nav fixed wing idle launch motor delay, which is quite a mouthful, but it is a really handy setting, especially if you've got a model where you need 2 hands to launch it. For example, like a XUV Clouds, something quite big. What this allows you to do is have your transmitter on the floor, get everything set up. So you enable launch, arm, set the flight mode, raise the throttle. Normally at this point the idle would start, but with this set it doesn't. What you can then do is pick up the model, and after this timeout the idle starts. And at that point you can throw the plane, and it does work really well. It's a very handy setting. So you have a range here of 0, which is off, to 1 minute. So you can have up to a minute of idle delay if you want. I've got mine set to 5 seconds. It's a really nice setting, and all you need to do, if you double click, copy, so you can right click and copy, and then do set, and then paste it, equals, and then enter your time in milliseconds. So 5,000 is 5 seconds. And then you would of course just type save. So those are the iNav parameters for auto launch, and also an explanation of how you would set these up for your plane. But I did mention the idle throttle and the launch throttle. How do we know what to set these to? Right, so idle throttle, it can either be just a visual indicator like I have on this, so you could even set it to 10% throttle. You just want it high enough so that the motor is going to spin, so you know that it's ready to go. But the more productive use is to have it assist you with the launch, especially if you have bigger planes, that sort of thing. If you see people shaking the plane and then throwing it, they're doing auto launch wrong. You're not supposed to shake it at all. By triggering the launch, you can induce I-turn wind up, which will mean when you actually throw the plane, it's slower to react and could end up making it crash. If you find that the launch isn't working well and you're having to shake it to get that bit of thrust, this is when you should be using idle throttle. And you don't need to go full throttle with it, or you don't need your full launch throttle. You just need enough to give you a hand to keep the plane straight and give you that bit of thrust to get the plane in the air for the detection. Launch throttle is the one that we need to sort of actually work out with the plane or with the calculator. And what we ideally want is so that we are above the 1-to-1 sort of thrust to weight. So what I'll do is I'll get a battery plugged in, and then we'll jump into iNav and I'll show you how to do it using the spinny motorway. Right, so as you can tell, this is not my regular battery for this plane. I needed a 3S and this was the only one I had available. Well, that I could be bothered to find. So, right, anyway, let's get on with this. So let's head into outputs. Now, this is another thing that has changed since the last video. You will see that this is now in percent rather than in microseconds, which is what the old configurator used to be. So I think, again, I'm sure it was 2.4. And I have had questions about, you know, how do you actually get those values to put into the advanced tuning page when this is in percent and that's in throttle in microseconds. And I'll show you how to do that in this video, but it's pretty straightforward. So there is a mathematical calculation, but we don't really need that. We can just do it in our heads. Right, so this process, as I mentioned in the last video, we are needing to throttle up. So make sure that you have all the cables clear. Make sure you've got a nice firm grip. Make sure that everything is clear of this prop. We are going to go and we're going to click, I understand the risks. My propellers aren't removed, but I still understand the risks. And what we need to do is increase the throttle until we get to the buoyant point. Again, it could be slightly pushing up, but we basically want it so that the motor is providing enough thrust to take the whole weight of the plane. If we were to let go of it and it didn't want to fall over and cause all kinds of mayhem, it would just float there. What we're going to do is just raise the throttle. Right, so you could see that I was sort of trying to feel where it was by trying to unweight my arm, and to me it actually felt better at 98%, but I did lower it down because the launch throttle on this is actually set to 90%. So that's what you want to feel for. You want it to feel like it's sort of weightless. It's not actually pushing towards you, but I mean at the moment you can feel, even a plane this size, you can feel it's heavy, it's trying to pull towards the desk. But as the throttle increases, at that point it's, yeah. So yeah, you just want to feel it so all the weight of the plane is taken, and of course try and do this with a fresh battery. This battery is at basically its storage, so that's probably why it felt a little bit weak at that 90%, but it should feel like it's just trying to lift off. You've got basically slightly more than the 1-to-1 power to weight ratio. Right, so you notice that this is all in percent. So how do we convert that into our microseconds? Well, the easiest way is to stick a 1 in front and add a 0 to the other end. So that 90%, we would add a 1 in front, so that makes it 190, and then add another 0, so 1900. That's the easiest way to do it. Of course, if you're at 100%, that's 2000. But if you're at 99% throttle, it would be 199 and then add the 0. So that's the easiest way to do it. There is mathematics to do it, but you don't really need them. There is actually a tool. If you go to my website and we go to RC channel values conversion, we have 1000 to 2000 here. If we put in our 90%, you'll see in this one it's 1900. So you can use this tool as well if you want, and that will show everything that you need. So that's how you go from the percentage to the value that you put in configurator. So let's minimize that back down. And yeah, as far as setting up, that's basically it. But what I'll do now is show the alternate method for getting your motor values, and they are on my website. So I'll go back to the home page you're basically going in useful tools, and we're going auto launch throttle estimator. Now notice it does say estimator. It is mainly a starting value. You may need to tweak it, but when I was writing this, a lot of people gave me values that they've got working in real world planes, and they've been translated into this, and people have been using this and told me that actually, yeah, the settings are pretty accurate, so it does work quite well. If anything, it overestimates, so you may want to reduce it down. What we need to do is set a few things about the model. So the first thing is the propeller that we're using. So we have the diameter, which is 3 in this one. We have 5 on the pitch, and this one is a 3-bladed prop. If you don't know where to get those from, they are written on the leading edge of one of the propeller blades, and it's the inches. Some propellers have it in centimeters and inches. You need the inch measurement. Next up, we have the kV of the motor. Now, on this one, it's written in absolutely tiny writing, but 4100 is the kV on this motor, and then how many motors you have. So this is obviously one motor. Something like Reptile Dragon would be a twin motor, so it's 2 motors. If you've got a Hercules, that's 4 motors, you know, so on. So just how many motors you've got, you would enter that there. Then how many batteries in series. So this is the pack that I use in my Dart. So this is a 3S pack. So this is 3 in series. If you're using parallel packs, don't worry about the P part. So for example, if I had a double, it would be a 3S 2P. So don't worry about the P part, it's just the S part, the series, because that's what gives us the voltage. And finally, we need the all-up weight. So this is the flight weight. So this is quite a porky Dart non-250G. So battery, hatch. So 321 grams. And finally, at the moment, you set your location. At the moment, what this does is automatic, but I'm going to add something that allows you to tweak this. This is getting the average ambient temperature and average altitude in your country. And I appreciate that this may be different to your actual area, so I will add it so it fills in some fields that you can change. But once you've got that, you can click calculate. So the results that it gives you in blue here are the values that it's recommending for the launch. So it's saying this model doesn't need an idle throttle where it's so light and the amount of power it's got. So that is producing 0 grams of thrust. And it's recommending 1790 microseconds for the launch throttle, which is producing 325 grams of thrust, which down below is a table of what's going on. So we have the throttle levels, we have the volts, the RPM of the motor, and the thrust. So you can see at that 1790, it should be producing, with that motor prop and a fully charged battery, 325 grams of thrust. And that is using an average temperature of 8.5, which, to be honest, where I'm flying in the summer at the moment, it's slightly higher than that. That's why we're going to have it so that the fields can be changed. An average altitude at 75 meters. I'm actually right in the coast, so my average altitude is a lot lower than that. It's probably closer to 20. And then it calculates the air pressure based on the temperatures and the altitude. So that's why I'm going to make it so that these values can be tweaked, because it probably will have an effect on these. But so it gives you the theoretical grams thrust here. So it's slightly lower on this model than what I've got it set to. So, but to be honest, this actually goes like stink, so I probably could lower it to that. Or maybe round it up to the 1800, which will give me a little bit, of leeway if I'm going for maybe a second flight on this pack, because that pack will last 25 minutes easy with fun flying. So this is a pretty good estimate. With my AR wing, it actually overestimated and I reduced it slightly. So it's a useful tool if you don't want to be holding something with spinning propellers, or if it's quite a big model, it may be, I mean, I'm not being funny, but holding a Dart 250G up with a spinning propeller is, yeah, it's just it's as scary as drinking a Diet Coke or something like that. It's really not. But if this was a big drag with a KO motor on it on 12S, I wouldn't want to be holding it. So that's where I would definitely be using the calculator for that. But everyone has their limits. To be honest, the calculator is much simpler. But all you then do is take these values here that you want to use. So say I wanted idle anyway, just for the visual side, so I could have this set to 1000, which is off, and then take that and put those values into configurator for the idle throttle and the launch throttle. So that tool is there if you want to use it. But anyway, what I'm going to do now is head out to the flying field and launch this plane. We'll again go through the procedure and you'll just see how it works. Right, so we're at the field. Everything's set up, we've got our satellites, everything's plugged in, so we'll go through the procedure for the auto launch and then I'll head over there and chuck it. The first thing I want to do, as I said, make sure that we're in a non-navigation flight mode. So I'm in manual at the moment. The next thing that we'll do is enable auto launch. If you've got it permanently enabled, you don't need to do this, so launch mode enabled. Next, we will arm. Now we can select our end flight mode. So I'm going to put mine in loiter, and then the next step would be to raise the throttle to the exiting flight mode throttle level. So when it finishes the auto launch, it will be at the throttle you set now. So I'm just going to disarm quick because I don't want it starting on the floor. Once I've raised the throttle, the next thing that will happen is the 5-second delay for the idle throttle. Once that kicks in, we can throw the plane and get it up in the air. So that's what I'm going to do now. Just a little tip. If you walk a couple of meters in the direction you're going to throw the plane, it might help it track better. Obviously, at the moment, it doesn't have a heading. So if you arm it, walk a couple of meters in the direction you're going to throw the plane, then it may assist getting that plane flying straight. So there you go, guys. I hope you found this video useful. If you did, please remember to give it a thumbs up, click the subscribe button and the bell icon. That helps get the video out to more people and they can learn how to set this up too. Thank you very much to all the Patreon supporters, and I hope you all have a great time flying models like you stole them, and I'll see you on the next one.